see it.
All right, so today we'll be starting off with again your paper number one, topic 3C of chemistry, which is the shapes of molecules and ions. And why do different molecules and ions have different shapes? Now, there's a reason that is all based on the theory known as VSEPR theory, or we can call it the EPR theory as well. It's the valence shell electron pair repulsion theory. In IGCSE, we have thought that if someone tells us that draw an ammonia molecule, we can just show it like this, that ammonia is in the middle and three hydrogens are on the sides. Now, this is what we know in IGCS. Simple. Okay. But in
Yes.
actual, if you look at the shape, it's what? If nitrogen is like this, and we know that nitrogen has a lone pair as well, it has 5 electrons in its outermost shell. One of them is bonded with hydrogen,
Mhm.
one is bonded over here as well, and one is covalently bonded over here as well. Right? Is it clear?
Yes. You
Now
need to
this
show
lone
that it's
pair
shared.
is actually repelling the bond pairs as well. So the actual shape that comes out of nitrogen is something like this. This is the shape that actually comes of nitrogen. And this is what we're going to study in your AS, that how are the molecules in their actual shape? What are the actual shapes? What are the actual angles of any? It's not always that all of these are going to be equal. There's always a change in shape, a change in angle. That is all based on the electron pair repulsion theory. The electron pair repulsion theory states that the shape of a molecular ion is caused by the repulsion between the pairs of electrons, both bond pairs and lone pairs, that surround the central atom. The electron pairs arrange themselves around the central atom so that the repulsion between them is at minimum. For example, lone pair repulsion is the greatest. If lone pair and lone pair repel each other, there's going to be the greatest repulsion. Then comes the lone pair bond pair repulsion. So you should always know how to identify which ones are the bond pairs and which ones are the lone pairs. अगर आप
Yeah.
इनको देखो ये कौन से हैं, these are all your bond
Uh,
pairs.
bone pairs.
And if you look at this one, this is known as the lone pair, which is not bonding. And any molecule that
Yes.
you are given, you have to first tell how many bond pairs are there in the central atom. Always look at the
Mm-hmm.
central atom and how many lone pairs are there in the central atom. So the weakest kind
Yes.
of repulsion is the bond pair repulsion according to the VSEPR theory. So this theory is sometimes also called the valence shell electron pair repulsion theory, abbreviated to VSEPR. The first two rules are used to obtain the basic shape of a molecule or ion, and the third rule is used to estimate the values for the bond angles. The shapes of molecules and ions, if we study, for example, to obtain the shape of a molecule or ion, it is first necessary to obtain the number of bond pairs and lone pairs of electron around the central atom. It is always important that you have to first find out how many number of bond pairs and lone pairs are there. And the easiest way to do this is by drawing a dot and cross diagram. You can then
Yeah.
apply the guidelines listed in table number A as well. What molecules with multiple bonds as well? Okay, many molecules are the ones which contain multiple bonds. If they have more than one pair of electron, obviously they would be participating in more types as well. For example, carbon dioxide. Now, carbon, can you
Mm-hmm.
tell me how many electrons are there in the carbon outermost shell?
Yes. So 12. So
What are you saying?
it is. So it has 12 electrons. So two.
Does it have to have 12 electrons? Seriously?
Wait, no. Uh, 6 electrons. But so four.
Keep the periodic table with you. These are very silly mistakes. You won't get anything if these basics are not clear. So there are 6 electrons in the outermost shell. ठीक है, 4 electrons. Total 6 हैं. Outermost में 4 हैं. Is it clear?
Yes.
So you can see it has formed a bond on the right hand side as well. And it has formed a bond on the left hand side as well. So can you tell me how many bond pairs are there?
There are two.
Check again.
Four.
And lone pairs?
Uh, also four.
Check again. Where are the lone pairs? I can't see any lone pairs though. Carbon has 4 and all 4 are included in bond pairs. Where is the lone pair?
So there is none then.
There is no lone pair. Carbon has how many electrons in the outermost shell? Tell me again.
Four.
And all of them are participating in bonding, right? Two with oxygen and the other two with
Yes.
oxygen, right?
Yep.
So where is the lone pair? There are no remaining electrons. To determine the shape of a molecule containing one or more multiple bonds, treat each multiple bond as if it contained only one pair of electrons. So here's the table that you have to memorize, that if each double bond is treated as an electron pair, then the molecule is linear as well. For example, BeCl2, when there are no lone pairs or double bond pairs, or left or right pair. So whenever you are given a molecule, you have to determine, okay, for example, BeCl hai. A BeCl is forming two bond pairs and zero lone pairs. Something like the you can see it is bonding also on two sides as well. This would be a linear
Yeah.
molecule as well. We call it a linear molecule, which has an angle as well that we'll study in the next topic. Then, if a molecule has three bond pairs, zero lone pairs, it's going to be trigonal planar. For example, boron trichloride. Then we have four bond pairs, zero lone pairs. For example, you can see carbon has formed bonds with four hydrogens. This is known as a tetrahedral structure. Five bond pairs, zero lone pair is going to be a trigonal bipyramidal. For example, phosphorus pentachloride. Then
Yeah.
octahedral structure, for example, sulfur hexafluoride, which has actually expanded it octet as well. Then three bond pairs and one lone pair, like we just did over here, the NH31. Over here we had what? Three bond pairs, one lone pair. So the
Three
shape is
bonds and
always
one
gonna
lone.
be a trigonal pyramidal. Got it?
Yeah. Triangle.
Trigonal planar is when there are zero lone pair, three bond pair. Trigonal pyramidal is what? Three bond pair, one lone pair. Then we have
One.
two as well. Two bond pair, two lone pair. For example, in water, we call it a V shape, or we also call it, I guess, in Cambridge, it was bent shaped. In Edexcel, we call it the V shaped as well. Let's see ethene. The displayed formula of ethene is carbon double bond bonding with hydrogen, and there are no lone pairs on either carbon, because carbon has a total of four electrons and each of them are being bonded. Two with this carbon, one with this hydrogen, one with this hydrogen. All four are being used. Treating each double bond as an electron pair produces a planar molecule with 120-degree bond angles. So if you treat all of them, now this is a bond pair on one side, bond pair, bond pair. Now there are carbon is bonding on three equally sized, three equal sides, no lone pairs. So that would be trigonal planar. Got it?
Yep.
You should focus on the sides as well, not the pairs or something. For example, BeCl3, it's a linear molecule, its bond angle is going to be 180. Okay, then we have a trigonal planar. You have to remember the angles of all these shapes, what it's going to be. Then tetrahedral was four bond pairs, zero lone pairs. BeCl2 was two bond pairs, zero lone pair. Trigonal planar was three bond pairs, zero lone pair. Trigonal pyramidal was three bond pairs, one lone pair with an angle of 107. Because over here, the lone pair bond pair repulsion is greater than the bond pair repulsion. So the angle decreases to 109.5 as well. Then water. Now there are two lone pairs, even much greater repulsion. Now these hydrogen would be moving more away from each other. So they are now decreasing the angle. You give 104.5. This was two bond pair, two lone pair. Trigonal bipyramidal, five bond pair, zero lone pair. Up now in this such combination, there can be two types. The upmost and the downmost chloride are going to be 90-degree, while the rest of the chlorine, these three, are going to be 120 degrees. Got it?
Yep.
Octahedral is 6 bond pair, 0 lone pair. That is going to be 90 and 180. 5 bond pair, 0 lone pair was a trigonal bipyramidal, which was 90 and 120. And this is the table that you'll make in your copy today. All of it. Okay? And this is supposed to be memorized, nothing else.
Okay.
Here are the questions that you'll solve after the class as well in the last 10 to 15 minutes in a very quick speed. Non-polar and polar molecule. Can you tell me what does non-polar and polar mean?
Huh? What? Can you say it again?
I can't hear you. Speak louder. What does polar and
Can
non-polar?
you say what you said again?
Polar and non-polar. What's the meaning?
Polar molecules, they are the V-shaped one, the pyramid ones, weren't they?
What? Repeat.
The V-shape, the triangle.
Polar.
Yes, the triangle
No,
shaped
that is
molecules.
a completely separate chapter. That is a completely separate topic. That was shapes. This is polar. Where did you read polar? That is planar and pyramidal. Polar means charged. Polar means charged.
Charged.
Non-polar means uncharged. Clear?
Yeah.
A molecule that is charged or it is uncharged. Can you tell me what is electronegativity?
Negative negative ion.
Electronegativity. What is the meaning of electronegativity?
I don't know.
Electronegativity is the tendency to gain electrons. Got it?
Yeah.
And this tendency to gain electron increases as you go to the right of the periodic table and as you go to the up of the periodic table. That means that fluorine would be the most electronegative atom. And the one which is electronegative always gets a partial negative charge or partial positive charge as well. Okay, I guess you were absent. I sent a recorded lecture of that you maybe forgot to watch. I'll share it again and then you'll get what electronegativity is. You had a guest at your house. So
Yeah.
I'll just explain you again what's electronegativity. We know that ionic bonds, for example, calcium chloride, are always charged. We do know that calcium is plus charged, chlorine is minus charged. This is confirmed because these are ionic bonds. Ionic bonds are supposed to be charged. Are covalent compounds charged?
Yeah.
Why aren't they both non-metals? Why are covalent compounds charged?
So they are not charged.
They are not charged. But today we'll study in A levels that yes, they are charged as well. How? Carbon is a non-metal, oxygen is a non-metal. So what's gonna happen?
Gonna
Now
become
we're gonna
charged.
see which one of these is more electronegative. Does oxygen come on the right? I have told you that electronegativity increases as you go to the right and to the top. So which is more
Mhm.
electronegative, carbon or oxygen?
Oxygen.
So oxygen molecules are going to get a partial negative charge. It's a partial negative charge, not a permanent one. And carbon would get a partial positive charge because it is less electronegative. Partial
Less
charges
electronegative.
are used to represent temporary charged. Now we know that there's an electron pair shared between carbon and oxygen. Electronegativity high means that this electron pair would be closer to this oxygen. Over here, the electron pair would also be closer to this oxygen. It would be a little far away from the carbon. This is known as electronegativity. Clear?
Yeah.
Good. This is how molecules become polar as well. Let's look at shape and polarity. And before that, let me show you one small thing regarding electronegativity, and then you can understand the shapes of molecules as well. It's a very small, easy concept. Okay, let me.
How to get the most of Grammarly free. It's Kayla on behalf of Grammarly to tell
Recall that when atoms form covalent bonds, they do not always share their electrons equally. This is because the atoms differ in their electronegativity, or their ability to attract electrons. If the electronegativity for an atom is high, then it strongly attracts electrons. If the electronegativity for an atom is low, it does not pull at the electrons as much. We can look at this portion of the periodic table to help visualize the electronegativity of the first several elements. Notice the gradient of light blue to dark blue that indicates the increasing electronegativity of the elements. Look closely at the symbols for carbon and hydrogen. Notice that they have similar shading and close electronegativity values. This means that when carbon and hydrogen are bonded together, as shown in this methane molecule, both atoms have a similar ability to attract electrons. Neither element pulls more than the other. This type of covalent bond is called a nonpolar bond, since the electrons are more or less equally shared between the two atoms. The electronegativities of hydrogen and oxygen are very different. As you can see from the chart, the electronegativity of oxygen is higher than the electronegativity of hydrogen. Because of this, when oxygen and hydrogen are bonded together, as shown in this water molecule, oxygen pulls at the electrons more than hydrogen does. This causes the covalent bond between the oxygen and hydrogen atoms to become polar. In a polar covalent bond, one of the atoms, in this case oxygen, has a slightly negative charge since it has a greater affinity for electrons, while the other atom, hydrogen, has a slightly positive charge because its electrons are spending more time around the oxygen atom.
All right, have you got it a bit?
Yeah, I think so.
Good. So electronegativity is the tendency to gain electrons, and not like gain electron. It's just pulling the bond pair closer together. For example, if HCl is also a covalent bond. Okay?
Yeah.
Both of them are non-metals, but chlorine is more electronegative, so hydrogen gets a partial positive charge. The more electronegative one gets a partial negative charge. So the electron
Yeah.
pair that is shared between them is going to be a bit closer to chlorine. Got it?
Chlorine.
Exactly. The drift of bonded electron towards the more electronegative element results in the separation of a charge. This separation of a charge is known as a dipole. We call this a dipole that has been created, a dipole moment, where one of the most electronegative ones have got a partial negative charge, or we call it a slightly negative charge as well. And the less electronegative one has got a partial positive charge or a slightly positive charge. Each of the bonds in a molecule has its own dipole associated with it. The overall dipole of a molecule depends on its shape, depending on the relative angles between the molecules or the individual dipoles that can either reinforce one another or cancel out with each other as well. Now, when will they cancel out? Chlorine, a Cl2 molecule. Both of them have the same electronegativity. The dipoles cancel out with each other. So this is a non-polar molecule. Got it?
Yeah.
This is a non-polar molecule, whereas HCl would be a polar molecule. If the cancellation is complete, the resultant molecule will have no overall dipole and we call it non-polar. If the dipoles reinforce one another, the molecule will possess an overall dipole and it is said to be polar. Diatomic molecules, for example, they are all non-polar, H2, Cl2, N2, because the two atoms in each molecules are the same, and so they have the same electronegativity as well. The distribution of electron density of the bonding electrons in either molecule is totally symmetrical, and hence the bond in each is therefore non-polar as well, and overall the molecule becomes non-polar as well. However, the bond in hydrogen chloride molecule is pure polar. Why? Because the electronegativity of chlorine is greater than that of hydrogen. So this is a polar molecule. The electron pair between HCl would be closer towards Cl because it has a slightly negative charge, being more electronegative, and hydrogen has a slightly positive charge. Since this is
Yes.
the only polar bond in the molecule itself is overall called as polar as well. The following symbol is used to represent a dipole. For example, this is how you show an HCl overall dipole moment as well. Then linear molecules में अगर आप देखो, there's a example of carbon dioxide as well, where both bonds in the carbon dioxide molecule are polar, but the dipoles are cancelling out one another. Like here, the carbon dioxide molecule is therefore non-polar. Trigonal pair molecules में अगर आप देखोगे, we have BCl3. In boron trichloride, this is also a polar molecule. Why? Because all three chlorines are more electronegative than boron. Boron comes on the left side of the periodic table, right? Chlorine comes on top and right hand side. So it's obviously more
Yeah.
polar. Okay? But
Positive.
due to these cancellation, because this is minus, minus, and minus, they all cancel out each other. This molecule becomes non-polar. Then tetrachloromethane. Again, the molecule is non-polar. Why? Because all these dipoles are similar. It's not that one of them was nitrogen, all of them were chlorine. So this is also a cancellation point where they all cancel out each other, becoming a non-polar molecule. What about this molecule? Over here, one of them is what? A different one. Over here, all of them were four chlorides. यहाँ पे
Same.
three chlorides हैं, but one hydrogen. This is gonna be a polar molecule. Why?
Because one is positive, another one negative.
Exactly. All four bonds are polar, but although the molecule is symmetrical, the dipoles reinforce one another, and so the molecule becomes polar. What about NH3? Is it polar or non-polar?
Uh, Polar.
Polar because there's a lone pair over here as well, and all NH
Yes.
bonds are polar, and the dipoles reinforce one another. The molecule is polar. यहाँ पे क्या था? That this bond and this bond, two are polar over here, two are polar over here as well. They cancelled out each other. Then water is the most polar molecule. ठीक है, यहाँ पे भी आपके पास due to lone pair repulsion as well एक charge आएगा ना. Oxygen would become slightly negative. Both the hydrogen would become partial
We become
positive
positive.
as well. So the polarity of a molecule is measured by its dipole moment, and you are not supposed to remember the values of dipole moments. You just have to remember or look at the period that which one would have a higher electronegativity, the rightmost and the upmost. Okay, for example, if you talk about Na and Cl. Now Na is the most left one, Cl is the most right one. And it is also obvious because these are already metals and these are already non-metals. यहाँ पे तो we already know it's obvious है, हमेशा से पता है कि यहाँ तो obvious है, वो non-metal हमेशा negative ही होगा and positive हमेशा positive ही होगा metal. But if we have two non-metals, for example, nitrogen and oxygen, now both of them are non-metal, but oxygen right पे आता है ना, so it has a partial negative and it has a partial
And
positive. They both
yeah,
can't have permanent positive and negative like metals and non-metals because these are both non-metals. So
not
the most
metals.
electronegative one out of those two non-metals would get a partial negative charge, and the less electronegative one would get a partial positive charge. Got it?
Yep.
For a diatomic molecule such as hydrogen chloride, the dipole moment is defined as the difference in charge and the difference in magnitude between partial positive and negative multiplied by the distance of separation between the charges. For a
Sir, can you
polyatomic
give
molecule,
me for
yes,
2 minutes? Can you give me 2 minutes, please?
can you speak
Give me
louder?
2 minutes, please. Can you
All
give me
right.
2 minutes, please?
Okay, okay.